Hello, everyone. I'm Arkin from Kansas State University. The study I want to share with you today is related to a very practical problem that we commonly see in the win-to-finish production. That is, how to deal with the leftover finishing feed from the previous term. When we budget for the last finishing diet, it often turns out to be not perfect, which results in the extra amount of finishing feed being left in the bins at the end of this term. And when this happens, the only two options we have is either to reclaim the feed from the bin, which is associated with the cost for labor and transportation, or we can feed it to the nursery pigs in the next term. But this creates the challenge that the finishing feed is going to take out some of our storage capacity and randomly contaminate the different phases of nursery diets. So the question for us is, how do we determine whether we should reclaim the feed or feed it? And if we decide to feed it, is there a specific phase or time window that we can blend the finishing feed in and result in minimum impact on the growth performance of pigs? To answer this question, we designed this study to mimic a production scenario. We assume there are 6 tons of late finishing feed left in a 2,200 head barn. On average, that is 2.5 kilograms of finishing feed per head of nursery pig. We'll blend this amount of finishing feed into the different phases of nursery diets and compare its impact on growth performance and production economics in the nursery pigs. In this study, we utilized a total number of 1,260 pigs with an initial body weight of 5.8 kilograms, and these pigs were weaned at 21 days of age. Pigs were housed in 60 pens in a commercial research barn with 21 pigs per pen, which gave us 15 replications per treatment. In a randomized complete block design, pigs were blocked by body weight and gender with 4 treatments and 15 replications. Diets were provided in 5 phases, and phase change was based on the diet budgets. This diagram hopefully will give you a better understanding of how the budgets and the blending process were arranged. The feeding budgets were expressed on a kilogram per pig basis. The different colors represent the different phases of nursery diets. So from left to right, we have phase 1 to phase 5. And the red color represents the finishing feed. So we have a total of 4 dietary treatments. And the first one is a control. The other with no finishing feed blended in, and the other 3 treatments received finishing feed in different phases. In phase 1, all the pigs received 2.5 kilograms of the common diet in phase 1. Then in the second treatment, 2.5 kilograms of finishing feed was blended in phase 2, and the blending process followed a specific order. That is, the half of the finishing feed were blended in first, followed by a 50-50% blend, and then finish up with the rest of the normal diet, nursery diet. We purposely designed this delivery sequence to mimic a real situation that the finishing feed was left at the bottom of the bins, and the new nursery diets were dumped on the top of it. So when we feed to the pigs, the pure finishing feed comes the first, then it comes with a blend of finishing and normal diets. In other 2 treatments, the finishing feed was blended in either phase 3 or phase 4 and followed the same delivery order. Then all the pigs received a common phase 5 diets, which concluded the 5 different nursery phases. The experimental diets were corn, soybean meal, DDGS-based commercial nursery diets. Phase 2 and phase 3 diets contained special proteins in a supplement form, and phase 4 and 5 were relatively less complex. The late finishing diet does not contain any specialty protein and contains only a very low concentrations of crude protein, SID lysine content, calcium, and phosphorus, which was compared with the standard nursery diets. Pen weights were determined every 7 days to determine the average daily gain. Feed delivery and blending were accomplished and recorded by feed logic system and to calculate the average daily feed intake. Data were analyzed using the glint mix procedure of ASAS with the experimental unit of the pen. The stats model contains the fixed effects of blending phase, which is our treatment, and also the random effects of weight block and gender. Move on to the results. In the next few slides, we're going to present the intermediate growth performance. To set up the figure, time or the feeding periods on the x-axis and average daily gain in grams per day on the y-axis. The blue line represents the pigs from the control group, and the red for phase 2 blending treatment, green for phase 3, and purple for phase 4 group. Since the phase change were based on the budgets, I labeled the approximate the time window for each phase to give you an idea when the finishing feed was blended in. From day 0 to day 7, all the pigs received a standard phase 1 diet, so no difference in average daily gain. When the finishing feed start to be blended in phase 2, we see a prompt decrease in the average daily gain, which is not surprising because the finishing feed only contained about half of the protein and lysine content than the pig's requirement. Similar response was observed in phase 3 and phase 4, but the magnitude of this reduction diminished as pigs get older. However, at the end of the nursery in phase 5, pigs all received a common nursery diet and had the same average daily gain. For average daily feed intake, again, no difference in phase 1 feed intake, but when the finishing feed was blended in phase 2, pigs promptly had decreased the feed intake. However, when the blending happened in phase 3, we did not see a decrease in average daily feed intake. And when we blend the finishing feed in phase 4, we see a slight decrease in average daily feed intake compared with previously fed blended diets. This means the pigs at this age were able to partially compensate for the impact of feeding finishing feed by increasing their feed intake. In phase 5, even though pigs were fed the same common diet, pigs previously received blended diets, especially those received blended diets in early phases, had decreased average daily feed intake than the control pigs. For the gain efficiency, no surprising that when finishing feed was blended in, it promptly decreased the gain to feed no matter in which phase. However, once the finishing feed was removed from the ration, the efficiency gradually recovers and becomes even better than the control pigs in the last nursery diet. Looking at the overall growth performance, blending the finishing feed in phase 2 resulted in a decreased average daily gain and feed intake than the control pigs. But when the blending happened in phase 3 and phase 4, it did not affect the average daily gain and feed intake. The overall gain to feed ratio was not different among the 4 dietary treatments. The final body weight is a function of average daily gain. Compared with the control pigs, blending finishing feed in phase 2 resulted in approximately 1 kilogram decrease in final body weight. And blending in phase 3 decreased the final body weight by 0.6 kilograms, but it was not statistically different. The blending in phase 4 did not affect the final body weight compared with the control pigs. From logistics standpoint, we would want to blend in the early phase to recover the storage capacity and avoid tandem contamination. However, our results show that if you make the blending too early, you get a penalty of almost 1 kilogram body weight at the end of the nursery. Finally, we determined the economics of feeding the finishing feed. We assumed a gain value of $1.32 per kilogram of body weight gain, and the feed costs were determined based on the recent ingredient prices. Blending finishing feed in phase 2 and 3 significantly decreased the feed cost, but also resulted in slightly lower average daily the gain value per pig. However, feed cost per kilogram of weight gain and also the income over feed cost were not different among the treatments. Go back to our test scenario. Remember, we have a 2,200 head barn. Based on the numerical difference in income over feed cost, the break-even cost for reclaiming the feed from the bins are $1,500 for phase 2 blending, $900 for phase 3 blending, and $700 for phase 4 blending. In the production systems we tested for, we estimated the cost of reclaiming feed from about $500. Therefore, it is more cost-effective to reclaim the feed rather than feed it to the nursery pigs, no matter which phase we can blend it into. To summarize, blending the finishing feed to the nursery diets will promptly decrease the growth performance of nursery pigs. However, the magnitude of this negative impact would decrease as pigs get older. In this study, when we feed the 2.5 kilograms per head of finishing feed to the pigs, which were 21 days old or greater than 10 kilograms body weight, the overall growth performance was not affected. However, comparing the production economics and the cost of reclaiming feed, we should not feed the leftover finishing feed to the nursery pigs. Thanks for your attention. I'll be happy to answer any question that you may have.